Good morning, boys and girls, and welcome back to day 2 of performing operations with complex numbers. In the previous section, we worked on adding, subtracting complex numbers, and simplifying radicals that contained imaginary numbers. Today we're going to continue on with this discussion, and we're going to talk about multiplying complex numbers and dividing complex numbers. But first, let's play around with a little properties of when we multiply complex numbers. We've already talked about if you have I to the first, that's just I. And we talked about yesterday I squared, which is technically I times I. That is defined as -1. Okay? I to the third, which is I times I times I, or you could write that as I squared times I. Well, we just talked about I squared as -1 times I then, or this would be -I, okay? And then I to the fourth is I times I times I times I, or it's I squared times I squared. We just said I squared is -1 times -1, and -1 times -1 is 1. Alright, so let's go back and look here. I to the first, we said is I to the second is -1, I to the third is I to the fourth is 1. I to the fifth would be I to the fourth times I, or I times 1, which is I. And if you keep going here, you're going to see that, hey, there's kind of this little pattern that happens. I get I, -1, I, 1. I to the sixth would be -1. I to the seventh is I, and I to the eighth is 1. Okay? And this pattern is just going to sit and repeat and repeat and repeat. That's why you'll never see an I with a power higher than 1. Okay? Because if it's got a higher power, I to the 6th or I to the 7th or I to the 27th, we're always going to want to simplify it and reduce that. Now, because there is this pattern, to do a power like I to the 27th, you could, there's a few ways you could do this. You could set up your pattern. Some people like to do this and be like, okay, so I've got I, and then it's going to go -1, then -I, and 1, and they just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and so on. And you can count until you got to 27, and whichever one you landed on, that would be your answer. Okay? That's a little bit of work and a lot of counting. So another way we have of doing it is, if you just take 27 and you divide by 4, because there are 4 numbers in our pattern, or 4 things in our pattern. 4 goes into 27 6 times. That's 24. We subtract. I get a remainder of 3. Really, this 6 just represents I've gone through the pattern. I went around that circle 6 times. Okay? What I really care about, though, is this third. This third really tells me, hey, this is going to be the same as I to the third. Or if I go 3 more times, we get -I. All right? So, if you're doing a high power, I think the easiest way to do it, to sum up what we just talked about there, is take the number, divide it by 4. You really want the remainder. Put the remainder on your I and evaluate those. That way you just need to know the first 4. I, -1, -I, and 1. Okay? Makes it easy. All right. When we're multiplying, we'll come back to those things occasionally. All right, moving on. Just regular multiplying now. I've got -6 times 2 minus 3i. Just like with adding, subtracting, this is exactly like we do with regular variables. I'm going to distribute the same exact way. And I'm going to go -6 times 2, which is -12. Multiply coefficients like normal. And then -6 times -3i is positive 18i. Okay. I know I kind of almost ran out of time yesterday's stuff, but I'm sure we've talked about it. But if not, you always want to write your complex numbers in this form. The real part, then the imaginary part. It's got to be in that order all the time, every time. Okay. Those are not like terms, so we can't go and put them together. Okay, next one now. Here we need to double distribute. So 1 times 2 is 2. 1 times negative 8i is minus 8i. Negative 4i times 2 is minus 8i. And then negative 4i times negative 8i is positive 32. I times I is I squared. All right. Now going back to what we talked about above, you're never going to see an I with a power on it. If I've got an I squared, I have to take this thing and I've got to make it I squared is negative 1. So what we do is we cross that off, and I just go and change the sign. 32 times negative 1 is negative 32. So you can just cross off the I squared and change the sign of the number in front, and then you'll be good to go. So now I need to combine like terms, and I've got 2 and a negative 32 gives me negative 30. The real stuff goes in front. Negative 8i minus 8i is minus. And we only get I squared when we multiply. If you're adding, subtracting, they stay exactly the same. All right. Let's try this one more time here. 4 times 3 is 12. 4 times 2i is 8i. Negative I times 3 is minus 3i. And negative I times 2i is minus 2i squared. Because there's really a negative 1 in front of the I, so negative 1 times 2 is negative 2. And then I times I is I squared. All right. Now I say I have that I squared, and I got to simplify that. So we said what we're going to do is go ahead and you can just kill off the squared, but you need to change the sign. So that's going to go from a minus to a plus. And so now I've got 12 plus 2 is 14. 8i minus 3i is plus 5i. Again, always the real stuff in front and the imaginary stuff in the back. Okay, moving on to complex conjugates. All right. You've heard me mention the word conjugate before when we talked about radicals, and we brought that up a little bit. Complex conjugates are the same thing, except it's just with complex numbers. If I've got a plus bi is my number, its complex conjugate, you need the same number in front and the same thing in the back. So I need an a and a bi. It's just now that I changed the sign in the middle. So a plus bi times a minus bi is a complex conjugate. So similarly, if you look down below, I've got 3 plus 9i times 3 minus 9i. Those are complex conjugates. Same numbers in front, same numbers in back. One's a plus, one's a minus, and this will come up a bunch. So if I'm going to multiply complex conjugates together, again, we're going to double distribute just like normal. 3 times 3 is 9. 3 times negative 9i is minus 27i. 9i times 3 is plus 27i. And then 9i times negative 9i is minus 81i squared. And again, what we like about conjugates, what we liked about them with radicals, is it killed the radical off. And then same thing with complex conjugates. If you watch here, it actually is going to kill our i's off. Kill our i's off? That sounds crazy. All right. The way that's going to work is negative 27i plus 27i are going to kill each other off. And then I'm going to have this I squared here. So I squared becomes a negative 1. So I cross that off. And I change the sign in front to a plus. And now you just get 9 plus 81 is 90. All right. When you do this, and we start doing more of these, if you recognize you have a complex conjugate, we say be smart. You don't have to go and do all that work we just did. Another way to do this, if you recognize you have complex conjugates, is you can multiply the fronts, and I can multiply the backs because I know all the other stuff is just going to kill itself off. And so now I can just go change my sign, make it a plus, and I still end up with 90 with a little less work. Okay? But if you recognize you have a conjugate, I'm going to say it's okay. You can just multiply the fronts, minus, multiply the backs, and put those together. All right. Now, just like with radicals, when we're dividing, we never wanted a radical left on the bottom, okay? Because we couldn't divide by an irrational number. Same thing here is whenever I've got an I on the bottom, I can't do that because I can't divide by an imaginary number. It's impossible, at least for us. So, very similarly to what we did with radicals, we're going to do the same thing with i's. If there is an I on the bottom, that negative 3 I'm okay with. It's just the I that I don't like. So I'm going to multiply the top and the bottom by I. On the top, when I multiply by I need to distribute. So I get 5I minus 6I squared. And on the bottom, I'm just going to get negative 3I squared. And now when I do this, you'll notice again we have those I squareds. Anytime you see an I squared, you got to know that's going to be a negative 1. So cross it out, change your sign. Cross it out, change your sign. Now, I just have some issues with my answers because it's always got to be in the right form. I need the real number in front. So now 6 becomes the real number. So that's going to go in front. Plus 5I all over 3. Now, you might see your answer like this, and that's totally okay. But you also, if you leave it like that, that's fine. But just so you know, on like maybe a multiple choice question, it might look differently. Some of our answers tonight, we might make them look differently to make you do this. But another thing I can do with this is I can split it up so I have like the entire real part and the entire imaginary part. So they might do that, and they might split it up. You got to divide both the front and the back thing by the number. 6 divided by 3 is 2. And then this we're just going to leave as the fraction 5 over 3I. Or it might be 5I over 3. But both these answers are the same thing. Okay? And the reason we're bringing this up is on a multiple choice, you know, they might have that answer or they might have this answer. You've got to know how to get to either one. Okay? So know how to manipulate your answers. Don't freak out just because you don't see the one that you got. All right. Last question here, and then we are done for today. 1 plus I over 3 minus 2I. When we have this plus or minus, just like yesterday, that causes us some issues. So the way I'm going to get rid of it now is I'm going to use that conjugate like we just talked about above. So I'm going to multiply by 3 plus 2I on the top and bottom. 3 plus 2I. All right, so on the top, I've got to double distribute. 1 times 3 is 3. 1 times 2I is 2I. I times 3 is 3I. I times 2I is 2I squared. On the bottom, we said we can take a shortcut, and we can just multiply the fronts. 3 times 3 is 9. And we can multiply the backs. Negative 2I times 2I is minus squared. Okay? Or minus the backs. I now just got to deal with those I squareds. That becomes a negative. That becomes a positive. And so I get 3 minus 2 is 1. 2I plus 3I is 5I. All over 9 plus 4 is 13. And again, you might leave it like that, or you might need to split it up. So there's one answer. And I come up over here. Or you might need to split it up as 1 over 13 plus 5 over 13I. Either of these answers are okay. All right, well, that's all I got for you today. Boys and girls, enjoy, and I'll see you again tomorrow.